two variable systems, this shouldn't be crazy different. It's going to be the very same process. It's just going to be more columns of numbers. Okay. So let's look at the steps for solving three variable systems. So yes, I want you to write out the steps, but to be honest with you, I think that you'll find that you probably can follow similar steps to what you just did for two variable. So remember what a three variable reduced matrix looks like. Remember the ones are in a diagonal, and then you have some numbers at the end, which are your solutions. So again, we're going to go in a very structured, methodical way, and we're just going to get the numbers to be what we want them to be, okay, using our three row operations. So here are the steps for solving three variable matrices. Matrices are the plural form of matrix. So the first thing you do is you start with column 1, just like you did with two variables. Okay, what do you want column 1 to look like if it's three variable though? You want a 1 on top followed by what under it? 0, 0, right? So you are going to, just like you did before, you're going to get the 1 in place first. And how did we do that before? We did a row swap occasionally, right? That doesn't work every time. Or more likely, we're going to multiply by the what? By the reciprocal. And then step 2 is to get the zeros in place for that column. And to do that, remember, you're going to add multiples of another row. But we always use what kind of number? We always use the opposite sign. And you're going to use the row with the 1 in it to make your change. So step number 2 is you're going to move on to column 2. Remember what you want for column 2 though. So if you need to, look above. What do you want column 2 to look like? Not 1, 0, 0 this time, but what? 0, 1, 0. Okay. So you're going to repeat steps A and B. And the gist of steps A and B is get the 1 first and then the zeros. If you always follow that general process, then you're going to be able to do these just fine. The third step is to move on to column 3. But what do you want column 3 to look like? 0, 0, 1. Okay. And again, you're going to repeat steps A and B, get the 1 first, followed by the zeros. And then last but not least, you're going to write your solution as a point and check it. And the check step is optional, but it's going to be really useful for us to be confident that we did it right. All right, so if you understood what we did with two variable systems, this is not really that much of a stretch. It's just a little bit more work because there's more numbers and there's one more column, okay? So let's say I asked you to solve this using a matrix. By the way, we had another way we solve three variable matrices, okay? That's actually what your quiz was in class today. That's what you were supposed to use. And so this is a second way to kind of solve three variable systems. So let's say that this is your three equations. So x plus y minus z equals -2, and then so on and so forth. Okay, so the first step is to first just write it as a matrix. So 1, 1, -1, -2. If you happen to run into one where there's something missing, you just put a 0 in its spot. So first you want to write the matrix. So what do you notice you kind of got for free here? Where would you have normally started? The 1, what do you notice is already good to go? The 1's already good, right? So we're just going to skip to the second step, right? So what do we want here and here? What do we want both of these to be? We want both of these to be zeros. Okay, so we're just going to do it one at a time. So how are you going to make a 2 a 0? -2, right? So you're going to do -2 row 1 plus row 2. That's what I meant by use the row with the 1 in it. And then what about this one? I don't even need to do any work, right? I can just add that to row 1, right? So I'm just going to say row 1 plus row 3. No need to even do any multiplying there. So notice which row's not changing? Which row's not listed second in either statement? Row 1, right? Row 1 is not changing. Let me slide that over. So you've got two commands, and I just like to start with the easy one first. So row 1 plus row 3, 1 and -1 together, 0. 1 plus 2 is 3. -1 plus 2 is 1. -2 plus 1 is -1. Be really careful about your signs, but go as slowly or as quickly as you feel comfortable. So what about this one? -2 row 1 plus row 2, right? So -2 plus 2 is 0, just like we wanted, right? -2 times this would be -2 plus -1 is -3. -2 times a -1 would be 2, plus 0 would be 2. And then lastly, -2 times -2 is 4, plus 5 is 9. So we're not by any means done, but what is done? The first column looks good to me, right? Like all of those look good to me, okay? So let me make sure that I didn't make an error here. So what did I get here? Oh, I don't know why I wrote that as a 0. What should I have written this as? Don't do something goofy like I did. I just copied the number down wrong. This wasn't a 0. It should have been a what? A 1. So that is going to change this number to a 3, but everything else is going to stay the same. Because I had the wrong number there, so I had to up it by 1. Sorry about that. So don't make goofy changes like that. I literally copied a number down wrong. You really don't want to do that. All right, so column number 1 is good. So what do we move on to next? Specifically this spot, because that's where the what should go. That's where the 1 should go. So notice I want a 1 here. Okay, so don't overthink that. How do you get a 1 where you want it? By the way, you would not want a row swap here. How come? If you row swap, you'll get the 1 here, but what will you screw up? This right here, right? So you don't want a row swap in the middle, okay? So I'm just going to use the reciprocal, so I'm going to do -1/3 times row 2. So notice that means that rows 1 and 3 are not going to change. But row 2 is just going to divide by -3. So this is going to be 0, 1, -1, and -3. So notice if you're keeping score, we're good here, here, and here, and now there. Okay, so now what? We move on to what? These two, and we want zeros here. So for this one, I want that to be a 0, so I'm going to use -1 times row 2 plus row 1. That'll get me a 0 there. And I'm going to use a -3 to make this 3 a 0. So -3 times row 2 plus row 3. Notice we're changing rows 1 and 3 by using row 2. That's kind of how it always works. So row 2 itself, though, isn't changing because it's not listed second in either command. So negative row 2 plus row 1, -0 plus 1, that's still 1. -1 plus 1 is 0, just like we wanted. This would be 1 plus -1, so it would be 0. And then this would be 3 plus -2 would be 1. Negative 3 row 2 plus row 3, 0 and 0 stays 0. Negative 3 plus 3 is 0. Negative 3 times negative 1 is 3, plus 1 is a 4. And then negative 3 times negative 3 is 9, plus a negative 1 is 8. So we're getting super, super close, right? We're good here, 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 and here. Okay? So now where do we go? We move on to the third column, specifically which number comes next? This number, right? Because I really would like a what here? A 1. And I can do that relatively easily, right? How could I get a 1 where I would like it? Multiply by its what? Reciprocal. So I'm going to do a 4th times row 3, which again means that rows 1 and 2 are not being changed. Actually, if you look at row 1, it's actually finished. So I don't even want to touch row 1. So I'm going to get 0, 0, 1, and 2. So actually, what you should notice is this is good. All this is still good. This is good, but I actually got that as a bonus, right? That's actually good as well, right? So I actually have one change left. What do I really want this guy to be? I want this to be a 0. And then I'll be all good and I will have my solution. Okay, so how do you get a number to be a 0? You add the opposite number, right? And we use where the 1 is. So we're going to take row 3 plus row 2. Remember, we need to list row 2 second because that's what's changing. So first and last rows are done, so we're carrying those over. And then this is a relatively easy command. So 0 plus 0 is 0. 1 plus 0 is still 1. Negative 1 and 1 is 0. Negative 3 and 2 is negative 1. Okay, so we're finished, right? Because what is this telling us? X is 1, Y is negative 1, and Z is 2. So the solution that could be checked by plugging it back in is what? 1 comma negative 1 comma 2. Okay, so is 3 variable systems, are they longer than 2 variable systems? Yeah. Sure, absolutely, okay. But is the math individually any harder? I don't think the math's any harder, there's just more of it to do, right? You might have to go a little bit more slowly. But remember, you also have another method for checking 3 variable systems. That was what was due on your quiz today, okay? So just moving forward, I want to talk about this. I looked at the homework just to remind myself. There is only one problem on the homework that's a full-blown solving 3 variable, okay? There's other problems where it's like, do this row change and tell me what the answer is, but there's only one where it's full-blown solving, okay? And on your exam, just to maybe ease your mind a little bit, I'm only going to do 1 3 variable full-blown solving, because why? It takes a long time, right? It takes a lot of paper, it takes a lot of thought process. So what I might do on test 3, just to kind of get yourself ready for the review time next time, is I might give you 1 full-blown 3 variable, but I might give you one where I just say, hey, do these row operations. Like where I give them to you and you tell me what the new row would be, okay? But as far as full-blown solving X, Y, and Z, you'll only have one of those, okay?